Welcome to Cookie's Maths and Science Hub. Today we'll be learning all about linear equations, how to plot them, and how to find the midpoint and the distance between 2 points on a line segment. So, what is a linear equation? A linear equation is represented by the standard form y is equal to m multiplied by x, mx, plus c. Our y in this case represents our y value, our x value. The m represents the gradient, and the c, is our y-intercept. We'll talk more about what each of these terms mean and how we apply them in solving problems moving forward. Like most functions, we plot linear equations on the Cartesian plane. The Cartesian plane being a coordinate-based system that relates x values along a single plane to y values along a vertical plane. So our y equals mx plus c. Our y value is its representation on that vertical axis, and its x value is the representation on the horizontal axis. Let's go into detail now about the different parts and discuss how we use them to plot these equations on graphs. Starting off with our gradient, the gradient serves as a crucial element of our linear equation, and it is represented by the m in our standard equation form. The gradient is equal to the rise over run, or in other words, how far it goes up divided by how far it goes across. This gives us the slope of the line. It's also known as the rate of change, and is usually referred to this in science and other such things when you're looking at exactly what the slope represents, as well as with calculus, but that'll be for further studies in your later years. An important thing to remember is if the gradient is less than 0, it is considered a negative gradient and shows the line such as in the diagram below. Whether if it's greater than 0, it's a positive gradient and shows the line in the diagram below. Effectively, if it's a negative gradient, the line is sloped to the left. If it's a positive gradient, the line is sloped to the right. An important part of solving these equations and for drawing them on the Cartesian plane is knowing where the x and y intercept is. In other words, the intercept is where it crosses those horizontal and vertical lines. So the x-intercept where it crosses the horizontal line, and the y-intercept where it crosses the vertical line. To find where the line crosses the x-line, or that horizontal line, you let y equals 0 in your equation. You can then use algebraic rearrangement to solve for what your x value is at this point. Because if it's crossing that x-line, that means its y value is 0. Vice versa, in this case then for the y value, to find out where the line crosses the y line, you let x equal 0, or you could just take your c value. As we discussed at the start of this video, the c value in our equation of y equals mx plus c is the y-intercept. So this is where where the line crosses the y-axis. Now, if you let x equal 0, you'll see it just eliminates the mx term, which gives y equals c regardless. So it works the same either way. Okay, so now we have all the different ways we can find pieces of information about a line from its equation. We can see its x-intercept if we let y equal 0. We can see its y-intercept if we just take the c value or let x equal 0. And we can see its rise over run, or its gradient, or the slope of the line, from that m value. Using all these in combination, we can sketch our equations on the Cartesian plane. Let's look at a few examples now. Okay, looking at our first example, our form, of course, being y equals mx plus c, we have y is equal to 2x plus 6. Now, with any maths problem, it's always helpful to write out what you know. Realistically, it's helpful for any problem, English, science, history, to make sure you understand what you know before you attempt to answer the question. So, we know our y-intercept will equal 6. So we can take that straight away from our c value, because we know our c value is our y-intercept. We also know our gradient, or our m value, is 2. This means for every 1 it goes across, it goes 2 up. In other words, for every 2 it rises, it goes across 1 run. 2 over 1 being our gradient of 2. Now, to find our x-intercept, or where the line crosses the x-axis, we'll set our y to 0. So that gives us 0 is equal to 2x plus 6. Then we can begin to rearrange the equation. So we need to get x by itself. Remembering back to our algebraic rearrangements, and check out my video if you need to do a bit more practice, we have 2x plus 6, or 2 multiplied by x, add 6. So we always get rid of the thing furthest away from the x first. In this case, adding 6 comes second. So what's the opposite of adding 6? Well, it's subtracting 6. So we'll have negative 6 on the left-hand side, because when we take 1 from the right-hand side, so we take 6 away to get rid of that plus 6, we have to do it to the left-hand side as well. So we'll have negative 6 is equal to 2x. That leaves us with that 2 multiplied by x. The opposite of multiplication is division. So that will give us x is equal to negative 3, once we've divided both sides by 2. Plotting that up then, we know it goes through negative 3, 0, because that's our x-intercept. And we know it goes through 0, 6, because that is our y-intercept. We have a positive gradient, so we know it's going to be sloped to the right. And then we just draw a line that goes straight through those points. You'll see we didn't need to use the gradient specifically, but it's good to have the knowledge that it was positive, so it's sloped to the right. Let's look at an example now where you need to use the gradient more clearly within your problem. Okay, so our normal form is y equals mx plus c. In this case, we have y is equal to negative 3x. Now, you'll see we don't have a c value. That doesn't mean it doesn't have a value. It just means it's equal to 0. So we know our y-intercept is going to equal 0. We know our gradient, or our m, is negative 3, noting that I've included the negative there. And our x value, well, if we put 0 in for y, it's just going to solve for 0 for x as well. So in this case, we know that our line must pass through the middle point of the two axes, or 0, 0, the coordinate. Unfortunately, this means it's a bit more tricky, because we need to make sure we're using our gradient to account for the actual slope of the line, because we cannot clearly identify a different x and y intercept. So what does that mean? Well, we know that our gradient is negative 3. That means we know for a fact it's going to be sloped to the left, and we know that for every 3 it goes up, it must go 1 across. However, we must also have a negative in there. Now, if we look at our graph, and we start drawing that line, and we just draw a line that goes through there for now, we'll need a line that goes up 3 and across 1. Now, either one of those numbers can become a negative, but let's just look at the positive side for now. So let's go up 3 and then across 1. You'll see here that straight away across 1, we've gone to the left, so it's going to be negative 1. So it'll be 3 over negative 1, which gives us our negative 3. Now, manipulating those negatives can be a bit tricky. So the main thing to really remember is that it should go up 3 for every one it goes across. You can then correct for the negatives here and there when needed. Of course, the reverse of solving for the lines on the Cartesian plane given an equation is to find the equation given a line on the Cartesian plane. Let's look at an example now. So we have our line here, and we can see its y-intercept is 0, 6, or it goes through 6 on the y line, and our x-intercept is 5, 0, or it goes through 5 on the x line. So straight away, if we look at our form, we're trying to write it out as y equals mx plus c. So we know that our c value will be 6, because that's our y-intercept. It's where it crosses that y-axis. Now, the other thing we need to find is our gradient, and our gradient is equal to rise over run. Now, there's a little formula you can use to find gradients, which makes it a bit easier than trying to draw on the graph, which is y2 take y1 over x2 take x1. That meaning you pick two coordinates and you assign one as x1, y1, and you assign the other as x2, y2. Now, you'll usually have been given two coordinates or have to find them off the diagram. In this case, I'm going to use our two intercepts. So let's set our x-intercept 5, 0 as x1, y1, and our y-intercept 0, 6 as our x2, y2. So our y2, which is the first value we substitute in, is 6. Subtract 0, because that's our y1. And our x2 is 0 from our 0, 6 value. And our x1 is 5. So we have 0 subtract 5. Now, you'll see straight away that gives us negative 6 on 5, which is good because our line is sloped to the left. So we should know that we need to have a negative gradient. Writing that out as our full equation, we have y is equal to negative 6 on 5x plus 6. Okay, looking at a second example now, we have 0, 3 as our y-intercept and negative 3, 0 as our x-intercept. So we know straight away our c value in our equation will be 3 because that's our y-intercept. Now to find m, which is our rise over run, we can once again apply our formula, y2 take y1 over x2 take x1. So our gradient is equal to 3 take 0 over 0 take negative 3. And you've got to be careful there to make sure that negative is in the brackets, because what happens when we subtract a negative? Two negatives make a positive. So that means we'll be left with 3 over 3, which means our gradient in this case will be 1. You can see that on the graph quite easily in this case, as for every 3 it goes across, it is going up 3, meaning that for every 1 it goes across, it is going up 1, meaning our overall rate of change, or our slope, is simply 1. That means our y is equal to x plus 3. Remembering in algebra, the 1 isn't necessary to write, and having the x by itself indicates it is multiplied just by 1. Sometimes with linear equations on the Cartesian plane, you'll be required to find the midpoint between two set points. On the right here, we have a line, and we've been given the two coordinates, 0, 4, and another coordinate, negative 4, 1. We've been asked to find the midpoint between these 2 points. The midpoint is simply the center point between two assigned points. It can be found using the formula m, capital M, is equal to x1 plus x2 over 2. And our second coordinate is y1 plus y2 over 2. So effectively we need two coordinates. In this case, we've been given two coordinates on our graph. So my x1 value, I'm going to assign to my negative 4. And my x2 value, I'm going to assign to my 0. So I'll have negative 4 plus 0 over 2. And then for my y values, using those same coordinates, of course, I have 1 as my y1, so 1. And I have y2 equal to 4. So I have 1 plus 4 over 2. That gives me my midpoint of negative 2, 2.5. Or my x value is negative 2, and my y value is 2.5. If you look back at the graph and can see the coordinates, you can see that matches up with what we'd expect based on the diagram. At times, you may also be required to calculate the length of certain line segments of an equation on the Cartesian plane. This can be done using the concept of Pythagoras. Now, if you're unfamiliar with Pythagoras, I suggest you check in with my video on the concept. Pythagoras' formula is represented as a squared equals b squared plus c squared, where a is the hypotenuse of a triangle and b and c are its other sides. Looking at a line now on the Cartesian plane, you can see if we take this small segment here, highlighted by the two red lines, we can see it goes across 5 and drops 1. Straight away, you should be able to see with the dotted lines that I have created a triangle. So the line segment we're trying to find is our hypotenuse in this case. So we'd have a squared is equal to 1 squared plus 5 squared, as they take the values of b and c. So a is equal to the square root of 1 plus 25. So a is equal to 5.1. This is an easy way to find any section of line segment when you've decided where you're finding it from. You simply use the x-axis and the y-axis to figure out your unknown sides and then solve for your hypotenuse. Thanks for watching. Hopefully now you have a really good understanding of linear equations and can apply it to your work in the classroom. Be sure to like, share and subscribe this video and keep an eye out for further maths and science videos. Hope to see you again soon.